We know that genes are building the brains of these babies differently. And we're asking the question, well, can we detect those brain differences much earlier than we see the behavioral symptoms themselves?
The human brain is the most complex structure in the known universe, and we are in the middle of a scientific revolution to understand its inner workings. Join us for a conversation with world-renowned neuroscientists as they visit Rochester. I am Dr. John Foxe, Director of the Monte Institute for Neuroscience at the University of Rochester, and you are listening to NeURoscience Perspectives. So Helen Tager-Flusberg from Boston University, it's really a great honor for me to have this conversation with you.
It's a pleasure to be here, John. Thank you for inviting me.
Absolutely. I think we're going to spend some time talking about autism, but I also, we want to talk about you. So let's start out there. How did you end up being one of the top autism researchers in the country? That's my opinion.
Well, thank you, John. I have no idea. I think I was in the right place at the right time. I started out long before anyone had ever heard of autism. This was over 40 years ago. I was always interested in language development, and I was looking for a population where I could study language development, and I picked autism. Nobody in the group, nobody had studied it really very much, and I thought this would be a wonderful place to start.
Yeah. But why language development? How did you get to that?
Why I was interested in language, because language is the most intrinsically interesting, deep, and essentially human domain of functioning. Through language, we can understand everything about an individual. And language development itself is just such an amazing, remarkable process. And I just always found it extremely interesting and exciting. So that's really what motivated me, was to understand the process of language development, how a child goes from the age of 12 months, where they may or may not have one or two words, to being a 3-year-old 24 months later, speaking in full and complex and rich sentences, coming up with ideas and stories out of nowhere. And they do it
That's remarkable, really.
effortlessly. Yeah. And then there's the whole group of children who don't get there.
Right.
And I thought, at that time I was in an experimental psychology program. I'm not a clinician by training, but my interest was driven in part by the idea that if we studied children for whom acquiring language was not straightforward and who didn't end up in the same place, that would give us insight into what some of the mechanisms are that drive language development. This was a time when we couldn't look inside the brain, where we couldn't look inside the human genome. We couldn't use biology to help drive any of our work. We just were relying on behavior, and so the behavior of disordered populations would provide insight. But then you immediately get caught up in the problem itself, and from there on, my career took off.
Can we rewind the tape, because people watching in will immediately realize that you didn't grow up in this country. So take us back to London and how you transitioned from London to...
Right. So I did. I grew up and I was born and raised in London, and I was an undergraduate. I got my undergraduate degree at University College London. When I was growing up, I have a younger sister who has intellectual disability, who is quite verbal, but whose language never reached the point of full maturity. So I don't know that...
very personal connection to the...
I don't know that was... I think that's what drove me to being interested in psychology in general. I had been planning to study mathematics at university, but I also recognized that I probably couldn't make that next step in mathematics. And I found when I discovered the field of psychology, I thought, well, this is a science that I think would be very interesting to me. I was also toying with physics, but I was very good at physics, but I never felt that I understood the concept, so I could do it, but I felt like I didn't understand it. And I had the naive view that maybe, well, people I could understand, not realizing that, of course, people are infinitely more complex than physics particles are. Anyway, so that's how I started, but then
And then the jump from Britain to the US, how did that come about?
I wanted to pursue a PhD, and I couldn't see myself continuing in England. At that time, mid-70s, things were very depressed there. I looked around at the graduate students at University College London. They all seemed extremely morose and unhappy. The undergraduates all were having the time of their lives, and the graduate students seemed miserable. And then I came and visited the United States, and everybody here seemed like they were very purposeful and excited, and seemed to enjoy their lives as graduate students. And I always had a love of America. I think all along, part of me knew I would jump ship. I would cross the Atlantic and never go back, and that's what happened.
So now, you come to the US at that point where you were beginning to think about intellectual disabilities and language delay as part of the PhD, or when did that come in?
I was pursuing studies of language development in typically developing children. And then when it came time to pick my dissertation topic, I was in my mentor was Roger Brown, who was like the father of developmental psycholinguistics. And he himself was fascinated by language in all different populations: schizophrenia, aphasia, Down syndrome, foreign language acquisition, which is really interesting and important, the role of parent input. So he encouraged each of his students to sort of pick off a topic that they would sort of make their own. So I worked collaboratively with other students on studies of language development, but then when it came time to pick off my own topic, I turned to autism, not realizing that was an extremely rash decision, because at that time, the incidence was around 4 in 10,000. So and I was not a clinician. And so that was very presumptive of me to think that I could go out there and do this
find
work.
all of those kids.
Yeah, well, I traveled a lot to do so. And that I could do this without being a clinical psychologist. Because in England, you could do that. People didn't care what your credentials were. If you had interesting scientific questions, you could pursue them. And there was a group in England who had started to do that. And I had been fortunate enough and heard lectures from them directly. So I thought I could do that here. And then I discovered that's not quite so simple, but I persevered.
Well, now, let's go back to that incidence business, right? Because 4 in 10,000, 1 in 2,500 kids, when you started out, that was what people believed, that was the prevalence of autism. Today, it's 1 in 40, thereabouts.
40, 50,
40,
60,
50,
whatever number you would.
So what happened?
What happened to cause that increase? I think a lot of things, some of which we have some good evidence for and others for which we don't. We know that there were changes in the diagnostic criteria and our whole conception of what autism is, which now has more to do with the presence of particular traits, perhaps the low end of the normal distribution of particular traits. But we also have a lot of diagnostic substitution. So as the rates of autism have risen, the rates of individuals whose primary diagnosis is intellectual disability has declined precipitously.
Right. So recategorization
Yes.
of children who would formerly have been diagnosed with an intellectual disability, and now they're being put in the autism pot.
And there's two things going on
what's
there, I
driving
think.
that? Yeah.
One of it is that indeed they do have autism, and they did have autism all along, but it wasn't recognized because once you see the intellectual disability, you put one label on and you stop there.
Right,
And people
right.
were not very knowledgeable, and we didn't have many experts who could diagnose autism. So one of it is that they were probably previously misdiagnosed.
Right.
And understanding what the relationship is between autism and intellectual disability has always had a sort of murky history. And I think the second thing is, if you have intellectual disability, the same kinds of therapeutic interventions, for example, applied behavioral analysis in any or every one of its forms, is an extremely useful and important form of intervention.
Mm-hmm.
In fact, it started out being an intervention for children with intellectual disability and then switched to autism. Nowadays, you can't get ABA services if you don't have a diagnosis of autism. And so therefore, it becomes very important to provide children who you know are going to benefit from these therapies with the diagnosis that's going to provide them access to those therapies. So that's just one piece of the picture.
Right.
I think it's way more complicated than that.
Sure, yeah. Now, one of the things I know about you that our viewers may not know is that you're really famous in the field for being really a pioneer. You're the person who went where everybody else feared to tread. And that is that many of us who work in the autism field, we are inclined to work with what we call high-functioning children with autism. And we do it most likely really because they're much easier to work with. But of course, they're not nearly as afflicted. And you, right from the get-go, jumped right in. Well, or maybe not so.
No,
okay.
That's really not true.
But you have gone down and worked with the kids who are really have severe
but
autism.
that's really only been the last 8 to 10 years, John. I really didn't. You know, I said to myself, well, I'm interested in language, okay? You can't study language in an individual who doesn't speak.
Right.
So therefore, I only focused on children who had at least some spontaneous spoken language, okay? But time went on, and my career flourished, and we learned lots and lots of things along the way about language and social cognition and many other aspects of children and adolescents with autism. But at the back of my mind, I thought, but there are all those kids who don't speak. And we're ignoring them.
Right. And they need us most.
And they do need us most. But until I mean, really, I think it took me a long time to open my eyes to that. And at the same time, opportunities came about because it is, as you say, and as you know, because you have also been involved in work in this area, it is extremely challenging. And it costs approximately, I would say, 4 times as much to do this research as it does with the more verbal individuals with autism. It really does take a huge amount of resources to do this work. And so I was helped along the way. I received a pilot grant from Autism Speaks, which had become interested in this population. Actually, it was Portia Iverson from Cannes who insisted that Autism Speaks continue this initiative that she had begun before they merged with Autism Speaks. And so I got some pilot funding to investigate using eye tracking methods as an approach to exploring language comprehension in minimally verbal children. And so that was quite interesting. And then the NIH became interested as well. And I had already had a leg up with this, and I co-directed a workshop that looked into sort of who are these kids and what could we be doing for the NIH. I did that with Connie Cassery from UCLA, and I think that really set the ball rolling for me, and I think I became fully committed to the idea that this is where we need to be doing research. And coincidentally, I think at the same time as I was doing that work, we had people within the autism community itself who were beginning to push back against the kind of work that many of us had been doing, perhaps exploring language processing, exploring theory of mind impairments, whatever else we were doing, saying, this isn't useful to us. These are people within the autism community. That kind of work isn't useful to us. Why aren't you doing the research, which is important to me personally, and to the rest of my community? And so it's sort of interesting. I sort of stopped doing that work at a time when, there were also other forces saying maybe this isn't the most important work we could be doing.
Can you unpack that for us? What is the community crying out for? What do they want from the research community?
It started out, I think, with an interest, even sort of quite independent, very verbal, intellectually able people living on their own. Nevertheless, for them, language isn't a problem. That they have difficulty with social relationships, yes, okay, but hey, don't we all, right? Depending on how you define that. For them, some of the sensory issues were more, so if we're going to take a sort of more scientifically based research topic, people were not investigating the sensory issues as much. I think the exception is the group here at the University of Rochester under Dr. Luisa Bonetto. She's had a long-standing interest, but she was really way ahead of the curve of this. So I think there was that. But I would say since then, the cry from the autism community itself about what kind of research is more in the area of services and supports and less in the area of scientific research. So, I think we're getting a sort of more complex message about scientific research on autism that comes from the autism community, which is not to say that the needs for understanding a better way for delivering services these are really, really important.
The brass tacks of the day-to-day life of living with a child with autism, you're worried about getting your kid to the doctor, you're worried about GI issues. And of course, for our community, we are saying we really need to understand the basic neurobiology for ever to really get to meaningful interventions. But it's the long-term piece of that's further down the road, and it's not what people are dealing with day in, day out, struggling with it.
I will say that the work we're doing with minimally verbal children and adolescents, I think that it does resonate very well with the families. They understand that we do need to understand why these children don't learn to speak. I think for them this is important. I think it's even more important that we develop effective interventions, effective approaches to providing them with a means for communication. That's absolutely crucial, and I don't think the community of researchers, whether they're clinical or basic biologists, have yet stepped up to that responsibility. I think for me, I need to know why they don't speak and then can think about targeted interventions. But my colleague Connie Cassery at UCLA has already forged the way there
in terms
shown,
of actually providing interventions.
Yes, a combination we know of highly targeted intervention that trains social communication, joint attention, builds up the play skills, the motivation really to communicate, which
Right.
these kids need, coupled with an augmentative communication device, usually now an iPad. It used to be on the Dynavox. Actually is very helpful to get these children
Right.
to communicate more. So that's one thing. There's probably way more that we could be doing, and I'm hoping over the next several years to be exploring some of that.
Let's talk about biomarkers. So we've been talking about, so also in your lab, you use electrophysiology and imaging techniques to measure actual brain function. You know, talk a bit about why that's important, where it's leading us.
So biomarkers is a very general term. And there are different types of biomarkers that we could be looking for in the field of autism. We've been particularly focused on diagnostic biomarkers. So can we, instead of diagnosing autism on the basis of overt behavioral symptoms, which we know based on now a decade or more's worth of research by multiple groups of investigators, they emerge during the second year of life. Right. The exact timing may vary from one child to another. The exact symptoms that emerge first over time may vary from one child to another. There are subtle behavioral signs earlier that are a little less specific and a little less predictive, but nevertheless we see retrospectively certainly are related to the emergence, the slow emergence behaviorally. But what about the brain? Okay, we know that this is a highly heritable disorder. Okay, we also know that it's a genetically based even when it's not heritable. We study the heritable version in that we take babies who have an older sibling with a disorder. And we know now that about 1 in 5 of those babies are going to end up with an autism diagnosis. Right. And the question that we're asking in our work, and this is a collaboration between Boston University and Boston Children's Hospital, my main collaborator is Charles Nelson, who's a world-renowned developmental neuroscientist.
Very much so, yeah.
And really he's the driving force behind all the biology work I learn every day from him and our other collaborators who bring even more sophisticated approaches to analyzing our data. We know that genes are building the brains of these babies differently. And we're asking the question, well, can we detect those brain differences much earlier than we see the behavioral symptoms themselves? Yep. And so we've been collecting electrophysiological data, that's sort of electrical recordings from the surface of the head. It's completely non-invasive. The babies don't mind this at all. And we collect the data at regular intervals over the first few years of life. And then by the time the babies reach the age of 2 or 3 years old, we're able to confirm whether or not they meet criteria for a diagnosis of autism. And what we've been finding is that EEG, just resting EEG, in other words, the electrical activity that you collect from the brain before you even give the child a task to do, because we're also doing that, is itself highly predictive of whether this particular baby is going to end up with autism.
Right. And give us a timeline. Are we talking 8 months, 6 months, a year? Whereabouts are we starting to get that level of prediction?
So we've collected data. We collected 3, 6, 9, 12 plus, plus, plus.
Right.
Well, it's a little murky in our data because we have fewer babies at 3 months. We only added on the 3-month data point when
Later
we
in the
were
study, yeah.
later in the study. And we have the most robust data at 6 and 9 months. So 6 and 9 months look like it's the most predictive, but I have a feeling that actually 3 months, when we look at the developmental trajectories, we see that there are maximal differences early on, and that over time, the EEG signal becomes closer to what we see in the typical low-risk babies.
Right.
So there's a sense in which the brain, as it is now living in the world and taking in sights and sounds and smells and touch from parents, and they are socially engaged, and they are engaged with the world of objects as infants during this first year of life, their brains are developing rapidly, as are the brains of all babies.
Yeah, right.
And at some level, they are now the rhythms of the brain that we pick up with EEG become more similar to the typical babies. Nevertheless, there are still some differences. It's harder to use it as a biomarker later, but that's not to say that the brains are not different. They're going to be different in different ways,
right.
at that point.
Go with me on this. So imagine now, we're a year down the road and your EEG test turns out to be 100% predictive. You can absolutely say that this child at 3 months of age is going to go on to pick up a diagnosis of autism. What does that do for us?
Well, first of all, I would say step back a minute, John, and don't get so excited.
Okay.
Number one, we've only demonstrated that in infants who have an older sibling. We have no
Good
idea.
point. Yeah.
All right, the majority of children who are diagnosed with autism don't come from a family where there is already an older sibling. We don't know whether this biomarker is going to extend to the full population of autism.
Right.
That's number one. Number two, we don't know whether it is specific to autism. Would we see the same difference, the same biomarker? Would that predict also not to autism but to ADHD? Or would it predict to intellectual disability or developmental language disorder? So we don't know the specificity.
But
I'm less concerned
I'm with you
about-
there. I mean, obviously, I was positing something that was
Okay.
highly unlikely at this point. So there's absolutely a lot of work to be done.
Yes.
And really, we're probably looking at a decade or more of work being
Okay.
realistic, right?
Yes.
But again, somebody
If
waves
it
a magic
work-
wand.
If it works, and I'm quite convinced. First of all, it wouldn't concern me so much if it wasn't specific to autism.
Right.
Okay? Because I think to detect any neurodevelopmental disorder very early on in life is important, and it matters more that we're picking up a child, a baby who we know is at risk for some problem, matters more than what specific problem it's going
Yeah,
to be.
good
And we
point,
know
yeah.
now that there's way more overlap among all these neurodevelopmental disorders. They don't fit in neat separate boxes. So number two is less concerning to me, but I think we'd want to know that. But I think it fundamentally will change how we approach and how we will think about autism at a societal level. And I think we would have to take this quite slowly to prepare parents
Right.
for the idea that we can predict something at long before, a year or more before the behavioral signs are going to appear.
Right.
That is a whole different landscape.
Right.
And I think we need to think carefully and work with people who are experts in understanding how all these new directions in medicine can be more comfortably taken up by society. that I'm personally equipped to do. I'm not experienced with that. I think about it from the parent perspective, but I also think about it from the clinician's perspective. What is this going to mean to pediatricians? And I've only had informal conversations so far. Pediatricians would love this.
Right.
This takes off their hands a problem that they don't know what to do with in their everyday practice. They know that a significant number of babies coming through their well baby visits are going to end up with autism or another neurodevelopmental disorder.
Right.
And they deal with worried parents all of the time, and they don't quite know how to fit this all together. And they spend 15 minutes, that's the time they are allotted by the insurance companies, for their well baby visits, okay? And during that time, can that pediatrician pick up that, yes, maybe there's a subtle difference in the amount of babbling that this baby is doing? No, they can't do that.
No, of course not.
They don't know what to do. They've got a very worried mom. They don't quite know what to do with that. So even though by 18 months they're mandated to do screening, a pediatrician doesn't really want to say to the mother of an 18-month-old who looks like they've failed the screener, oh, I think your child may have autism. I'm going to recommend that you see a specialist. They usually try to pass it along. Oh, well, let's wait and see. When you come back at 2, we'll reevaluate. That's the way pediatricians do it, because they don't know how to deal with the evidence. They don't know what to make of it.
Right.
So an objective
test would really help them.
For them, they say the idea of a biomarker would be EEG. They understand.
Yeah.
So they would love that. The issue is no test is going to be 100%, John.
Right.
Okay. We're always dealing with risk markers that are probabilistic.
Yeah.
And so another whole piece of how we're going to cope with this, and I think this is going to come.
Yeah.
It's going to come, 5-10 years from now. And if it's not our biomarker, it's somebody else's biomarker. And it doesn't matter to me whose it is. But it will provide us with a way of screening universally that would be easily done. I like EEG because it's cheap. Mm-hmm. Okay? It's cheap, it's portable, it's accessible. This doesn't take very long to do, at least the measures that we have.
So Helen, going back to your training and your trajectory, you come from London, you end up at Harvard, and you're one of the only PhD students at Harvard that's a woman, is that?
There were some in the experimental program. It depends which program you were looking at.
Right.
I was in experimental, and we certainly had the fewest women in
so
our program.
So what was that like? I mean, what was it like to be a woman in the field in those days?
I think the world at large looked like that, the professional world. So I have a feeling that had I decided that I wasn't going to just get married and have babies at that point, which probably if you'd have asked me when I was 15, I'd have told you that is what I was going to do. I think I was the second generation, though.
I see.
Not a whole generation's worth. I think the women who started 5 years before me, they were really the pioneers, whether it was they were the first women in law schools, they were among the few women in medical school classes, whatever professional track, and certainly in PhD programs, especially in the sciences. They were really the pioneers. And I feel that so when I came in, I felt that I wasn't the only one, and that there were role models above me. Few, yes, but I think you only need one or two to be able
to blaze that trail,
to feel confident that you belong. And I would say I had a very supportive mentor. And even if some of the other professors in the program seemed a little more hostile, I think I didn't pay as much attention to that at the time.
Very good.
Yeah. And so I always felt that it was that group before me that really were the pioneers.
I was thinking when we were talking about your studies in London, and you mentioned mathematics and physics, but then you went to psychology and autism. Was part of turning your back on mathematics and physics because it was male-dominated? Or
No.
It wasn't that. That wasn't
No.
the decision point.
It was actually an extremely honest appraisal of my own
Very good.
skills
I see.
and depth of understanding and engagement.
Yeah. So young women out there today thinking about doing a PhD in the sciences, do you have a message for them? How do they get to be where Helen Tager-Flusberg is today as one of the truly renowned scientists?
I think what I'm going to say is that the most important thing to do is to develop time management skills. If you're not an organized person, and if you can't take a block of time and use it most effectively, it's going to be harder for you. I think you have to stay focused. Women are always vulnerable to being asked to take on more administrative responsibilities, more mentoring of students, more busy work, more of those things so that the men can get on with their lives. And that, I think, is still true today.
Right.
That has not changed. And I would say don't be succumbed. And I think we often do go along with it because at some level I think we still feel grateful that we are in these, that we have these jobs, that we do have this, and so therefore we're supposed to say yes.
So you still owe a little bit back or something, which is
definitely.
Yeah, isn't
yes.
that interesting?
And I think women need to find somebody who will help them stick to the stay focused, know what is your next step, know what's going to get you to the next step, and make sure that you're devoting a significant proportion of your time to doing that.
Right.
But never sacrifice the personal side for that. Sacrifice the administrative jobs, but don't sacrifice your personal life.
Right. That was fantastic. Thank you, by the way.
Oh,
that
thank
was
you,
really
John.
terrific.
You should be on CBS Morning News.
Is that right?
Actually, my colleague Chuck was on CBS Sunday Morning News last week.
Look at that. Yeah.
Yes. Basically taking this EEG data to argue that it can't be vaccines, guys.
Yeah, right.